Why venture off the beaten path to explore the unnecessary dark arts of long division? We'll find out soon enough if there is light at the end of this tunnel. To start off, we first need to know the format. Given the words divisor, dividend, remainder, and quotient, how does one weave them together into a formula? Let's examine using numbers to simplify the problem. 1000 divided by 70 gives 14 and a remainder of 24, which I can rewrite as an improper fraction. If I wish to eliminate the denominators, it can be done by multiplying by 70. This yields an equation like this. We know that 24 is the remainder. 70, which was the denominator, has to be the divisor. And 14 is the quotient. 1004 has to be the dividend. With that in mind, we can map the four terms to form a long division format. And onwards to the next obstacle. The question here looks easy enough, but what exactly is a degree? And how do you define a polynomial? The internet can solve these problems here. To paraphrase, a polynomial is an algebraic expression containing variables and coefficients. The powers of these variables are known as exponents. So in an example like this, the variables will correspond to x and y, while coefficients are the values attached in front of the variable. The powers of x and y are non-negative integers like 3 and 1, so this qualifies as a polynomial. As for a degree, it refers solely to the largest exponent, paying no attention to the other powers. In this example, the largest power would be 5. Holding on to these two new pieces of information, we have enough knowledge to crack the code and move on. In the first case, the largest power is 3. And in the second case, the degree is 5. You may be wondering what's the point of all these fancy terms, but we'll be applying these concepts very soon. The main problem with algebraic long division is when exactly does it need to be done within a fraction. Given that there are only 3 different formats for algebraic fractions, which ones qualify for long division? We start off with the first scenario, when the degree of its numerator is smaller than that of its denominator. Something like this, for example. Imagine a fraction like a cave, with the numerator as the roof and denominator like the floor. The numerator's degree is 2, and the denominator's degree is 4. In this case, this is a proper algebraic fraction and long division is not needed. What about another case where the degree of the numerator exceeds that of the denominator? This example has a numerator degree of 2 and a denominator degree of 1. Much like an unstable roof, this is an improper fraction, which requires simplifying into a more manageable form. In this case, think of long division as relieving the pressure of an unstable roof, which allows for more convenience in the advanced branches of mathematics. We'll not be covering these long division techniques in this video, but if you need to know, the simplified format looks like this. The last case is the most intriguing. What if the degree of the numerator and denominator are the same? A numerator of x plus 6 and a denominator of 2x minus 5. Looks straightforward, right? An innocent looking question like this, where both degrees are 1. It is tempting to skip the long division entirely for this question, but this banana skin may cause slip-ups further down the line. It does make you wonder, how would things turn out instead if long division was done first? Algebraic fractions contain variables which do not provide a sense of whether a fraction is proper, unlike numerical fractions where you can compare values. Adopting simplifying techniques early is a good habit. Working with proper fractions as much as possible is a helpful tip as it minimizes complications and yields useful clues. If you need to know, the long division format for this question looks like this. So what exactly are these mysterious math spells that require long division? Differentiation and integration, also known as calculus, are much easier to solve when algebraic fractions are simplified. The sketching of discontinuous curves, which involves a scary sounding spell known as asymptotes, are also easier to plot when long division helps dissect complicated looking fractions. Then again, this video isn't the right time to dwell on those topics. Click on the right video card if you wish to take an even deeper plunge into long division techniques. Otherwise, your ordeal ends here.